All right. So question one says a chemical balance is used for measuring density, mass, volume, or thickness. The correct option is mass. All right. So chemical balance is used for measuring mass. So whenever you see balance, right? Balance, anything balance is used to measure either weight or mass. The idea is, of course, like you're balancing something out, right? So you usually have two options or two spaces to place weights on, and then compare, right? And then somehow by the calibration, the setup is then designed to give you the mass or the weight. So like there are three balances popularly. We have spring balance, we have chemical balance, and then we have beam balance. All right. So spring balance measures your weight, but then chemical and beam balance measures spring balance measures weight, chemical and beam balance measures mass. All right. So I mean that's the only option that does make sense here. Mass, D and B. Okay. So number one is B. Number two says the diagram represents a portion of a micrometer screw gauge in which the horizontal scale is in millimeters. What's the reading on the instrument? Okay, so this is 0. All right, 0. This is the sleeve. This is the main scale. All right, so this is called the main scale or the vernier scale, and then this one is the circular scale. So this is the extra level of accuracy that we get. So this is the circular scale. So this main scale here we have 0, 1, 2, 3. All right. So this is 3 millimeters here, and we'll then read out of where the center line intersects with the circular scale. All right, so this is 3.1520. So that'll be 3.21 millimeters. All right, that's option D. That's option D. Okay, so you read the main scale first, then you read the circular scale. And how you read the circular scale is that you read where the center line on the main scale meets up with the circular scale. Okay, now this circular scale runs up to only 50, right? 0 to 50, and that's because you have 0.5 readings from the main scale also. All right, so this is 0, 0.51, 1.52, 2.53. So 3, and then so the fact that we didn't see the next one means that this reading must be between 3 and 3.5. Then we use the circular scale to know where between 3 and 3.5 it is. All right, so the correct option is option B. That's for question 2. Question 3. The diagram represents a section of a pair of vernier calipers. The reading on the instrument is what? Okay, so we have the main scale up, and on the main scale we can see that the main scale, the vernier scale reading starts at this point here. All right, so this is 1 cm. All right, 1.1 cm. Okay, so we already have 1.1 cm. So it's the second decimal place now that we're looking for, right? And to find that, we'll look out on the vernier scale to see where any of the markings on the vernier scale perfectly intersects with the main scale. Yeah, and we have that at 5. So that's why it's 1.15 cm. 1.15 cm. Because we looked at the main scale, we're able to get where the main scale, reading from the main scale. You just check for where the vernier scale starts. Where the vernier scale starts, which is this point, determines where you stop reading the main scale. All right, so that's 1.1. And then on the vernier scale, you now look for where you have a perfect intersection with the main scale to get you the next decimal place. So the answer is 1.1 from the main scale, and then the decimal place we got from the vernier scale is 5. That's 1.15. That's question 3. All right, so 1.15 cm. Okay, there's an error here. So 1.15 cm actually. That's for question 3. Let's look at question 4. Question 4 says, the diagram illustrates a micrometer screw gauge. Determine its reading. All right, determine its reading. Okay, so we have 0, 5, 6, 7. All right, so 0, 5, 6, 7. The readings on the, what I tell you is I tell you the 0.5, so this is 0, 0.5, 1, 1.5, 2, 2.5, like that. The readings on the are between the whole readings, right? So those ones give you 0.5. So, and then this other part gives you the other 0.5 extra accuracy. So the reading on the circular scale just runs up to 50. Okay, it doesn't run past 50. It doesn't run to 100, just 50, because you can get 0.5 from the main scale. So reading this here, I can see 5, 6, 7. All right, I can see 7. I can't see 7.5 because I can't see the one under, just 7. Now we can now read the circular scale, and the way you do that is that you look for where the middle line, the horizontal line on the main scale, intersects with the circular scale. So that will be here. All right, remember I already got 7 points. All right, so when I read it from here, I have 35, 36, 37, 38, so 7.38. All right, so the main scale gave me 7.0. Remember, it's in 0.5, so it could have been 7, 7.58, but we didn't see 7.5, we just saw 7. All right, the 0.5 scales are usually under, and so we got 7, and then from the circular scale we're able to get the 0.38 from there. That's for question 4. Let's look at question 5. Question 5 says, the diagram represents a portion of a micrometer screw gauge. What is its reading? Okay, so the way a micrometer screw gauge works is that we have a main reading here, and here we have the circular reading, attached to the symbol and all of that. So here you can get your accuracy up to 0.5 of a millimeter, right? So this is 0, 1, 2, 3, 4, 5, 6, 7. All right. But if you look under, you also have 0.5. So this is 0.5, 1.5, 2.5, 3.5, 4.5, 5.5, 6.5. So this last bit here is 7.5, and you can see it pops. You can see it so slightly. So that means that our reading from the main scale is 7.5. Now, the remaining 0.5 accuracy is gotten from the circular scale. All right, and the way you find out exactly what it's saying is that you look for where the horizontal line of the main scale intersects with the circular scale. So we have, that's at this point here, which is 24, right, just before 25. So that's 0.24. So we have 7.5 plus 0.24. So this is the main scale, 7.5. Circular scale is 0.24. You add them up and you have 7.74. All right, as your reading, which is option B. So 7.74 millimeters. That's for question 5. Question 6 says, the diagram represents a portion of a vernier caliper. What is its reading? Okay, so we have the main scale, this on top here. So this is your main scale. And then we have the vernier scale under. So for my main scale, what do I have? We can read it, 0 to 10, then 11, 12, 13, right? So you read your main scale until your vernier scale starts. So for my main scale, I can see that it is 13. I can say I got 13 point something. Let me just say 13.0. All right. And then for my vernier scale now, I would read to know what the, other decimal place is. Now, on your vernier scale, what you do is you look for where the marking on the vernier scale intersects perfectly with the main scale. All right, and then that gives you the tenth that you're looking for. So if you look at this, this happens here. This is at point 2 that you can see that perfect intersection. So I'm going to add my 0.2, giving me a reading of 13.2 millimeters. That's option D. So you read your main scale and you stop reading your main scale where your vernier scale starts from. And then for your vernier scale, you look for where it intersects perfectly with the main scale. And that will give you a tenth of, tell you how many tenths you're adding to your main scale reading. So the correct option here is option D. That's for question 6. For question 7 says, the dimensions of momentum are, so I think this should be is, right? I think dimension, anyway, momentum has a formula. The momentum is given by mass times velocity, which we can break down, right? So your mass is already fundamental, that is m, but your velocity is distance over time, right? So that's length L over time T. So mass, length over time. So this is basically m times L, over T. You could see it this way, or you could also see it written as ml T raised to the power of -1. ml T raised to the power of -1. That's option B. So that's option B. That's for question 7. Question 8, we go, joules is equivalent to what exactly when we break it down? Okay, so joules is the unit for work and energy, right? And let's go with work. Work is equal to force times distance. Distance is already fundamental, so we can represent this as m, right, in meters, because we are doing units, not dimensional analysis. So no need to say L, we just say m, meters, that's the unit. Now, force is mass times acceleration. This is kg times, we need to break down acceleration, then times your meters, all right? Your meters from your distance. What's acceleration? Acceleration is velocity over time, all right? So velocity over time. So we are still breaking it down bit by bit. Time is fundamental, so this is, and the unit is s, right? So I'm going to say kg over s. Let me write it this way so that this time can come here. Sorry, let me say second. So velocity per second, right? That's acceleration. Then times velocity is now distance over time, or displacement over time. All right, so this is going to be meter per second, then times your meters from before. So it's very important that you're careful and deliberate about breaking it down, step by step. So we end up with kg, then we have m, meter squared, because meter times meter, then over s squared. Okay, so they're represented using negative powers for the index, for the s squared. So it's just going to be kg meter squared s raised to the power -2, right? Because by law of indices, this s raised to the power -2 means that s squared is your denominator. So we can just write it out this way. Same thing. So the correct option is option D, right? kg meter squared per second squared. All right. Question 9 says, using vernier caliper, which of the following readings give the correct measurement of the length of a rod? Okay, so your vernier caliper, the main scale would give you your reading to, of course, the nearest millimeters, right? It's like your ruler, right? That'll give you a reading to the nearest millimeter. So that's 0.1 of a, that'll be 0.1 of a centimeter. Okay, so my main scale is going to be, since it's in cm, is going to be 0.1 cm accuracy. But my vernier scale provides me with a tenth. So it provides me with a tenth extra accuracy, which is 0.01 cm, right? So in total, the most accurate you can get is to 0.01 a hundredth of a centimeter. When you look at this unit, the only option that gives you your accuracy to a hundredth of a centimeter is option C. All right. So all of these are very well the same measurements, just provided to different levels of accuracy. But the one that a vernier scale, vernier caliper would be able to capture would be 4.13, because it's to the hundredth of a cm. That's question 9. Question 10 says, which of the following has the same unit as the moment of a force? All right. So moment is basically what? Force times distance. Which is Newton meter, right? Impulse is force times time, which you could say is Newton seconds. Force is just newtons, right? Power is work over time. Power is work over time, which is joules per second or Newton meter per second, right? Newton meter per second. But the one that has just Newton meters is work, because work is what? Force times distance also. All right, so they are exactly the same. The difference is that moment is force times perpendicular distance. That's just the difference, right? So moment produces a turning effect. All right, so that's just the difference, but they have the same unit fundamentally: Newton meters, Newton meters. So the correct option is option A. Now, whilst I would identify with the fact that a lot of us who are going through this if this is your first topic in physics, then probably a lot of these formulas are new, but on some hand, I'm still, grateful for that, because it just shows you that physics is all about formulas. Well, a huge chunk of it is about formulas. So you must begin to just familiarize yourself. I would advise you to, before you even have full understanding, begin to be deliberate about memorizing your formulas, getting used to them, having, learning them and all of that. That's it for question 10. All right, question 11 says, which of the following instruments is suitable for making the most accurate measurement of the internal diameter of a test tube? Okay, so I want to measure the internal diameter of a test tube. We're trying to find out what this distance is. Okay, so if you know what they look like, you would know that a micrometer screw gauge cannot measure inside, right? It's used for measuring the external diameters. So say if you had a ball or something, your micrometer screw gauge has something that presses on both sides from the outside, and then uses that to measure the external diameter, right? But for internal diameter, your best bet is a pair of calipers. All right, a pair of calipers has, it sits inside. It has the teeth that sits inside, and then is able to kind of like stretch out to measure. I think a picture of a pair of calipers would really help. But pair of calipers, yes, is used for measuring internal diameters. Micrometer screw gauge, even though it has more accuracy than the pair of calipers, is used for measuring external diameters. Okay, so a pair of calipers can also be used to measure external, right? So a pair of calipers can measure what's going on inside and what's going on outside. But then, the micrometer screw gauge has more accuracy than a pair of calipers, but it's only used to measure what? External. Okay, so your meter rule, that's like your regular ruler, right? It can, but less accuracy. Yeah. And same thing with the tape rule too. You might be, I don't know how you'd want to, stretch a tape rule out to measure what's going on inside of a test tube. But, the correct option is option D, a pair of calipers. Right, question 12 says, which of the following instruments is best for measuring the diameter of a thin constantan wire? So the correct option for this would be the micrometer screw gauge. right? Again, it has the highest accuracy. The micrometer screw gauge has the highest accuracy. And is useful for measuring the external diameters of objects, right? So the correct option is option C. That's for question 12. Question 13, which of the following is a derived unit? Okay, which of the following is a derived unit? The correct answer is coulomb. All right, unit for charge. Kilogram, this is for mass, right? So mass is fundamental. Meter is for length. Length is fundamental. Second is for time. Time is fundamental. Coulomb is for charge. Charge is not fundamental. All right. So charge is derived. So you need to learn your derived, your fundamental units. I think there are about 8 of them. All right. So if you learn your fundamental units, you know the ones that are not fundamental. I think that's the easiest way to go about, mastering which are fundamental and which are derived. Question 16 says, which of the following is a derived unit? Okay. So second is for time. Kilogram, is for mass. So these are fundamental. Ampere is for current, also fundamental. The correct option is ohms. All right, ohms is for resistance, is derived. So RIVED, sorry. So you need to learn your fundamental units. There are about 8 of them. All right, you need to learn all 8 of them so that you know what is not a fundamental unit. That's what's a derived unit. So you need to memorize and master your fundamental units. Okay, that's 16. Number 14 rather. 15 says, which of the following is a fundamental unit? Okay, so speed is not. Length is. All right, length is a fundamental unit. So there are about 8 fundamental units. You need to go learn them. Quantities and units rather. You need to go learn them. All right. So your fundamental units are just basic units that I feel like can be measured from nature. All right. So they are fundamental. But your derived units are gotten by combining multiple fundamental units, either by multiplying or dividing. So for instance, speed is meter per second, right? Meter per second. So it is length and time division to get what? Speed. Density should be mass over volume, I guess. Yes, mass over volume. So you are basically doing, mass, which is kilogram per volume, that's meter cube, right? So these are both fundamental units, but they are being divided. Volume is not a fundamental unit because volume is, L times L times L. That's length in 3 places, right? So volume in itself is already a derived unit. So it's kilogram, a fundamental unit divided by, length times length times length. So, that's a derived unit. It's not fundamental. Impulse is change in momentum, right? So you can use the momentum formula, which is mass times velocity, or you could also use what? More directly, you could go, this is change in momentum, mass times velocity is momentum, or force times time. All right, but either way, these are not, of course, these are derived units, or is a derived unit. So the correct answer is B, length. So quantity rather. So it's B, length. So you must learn your fundamental quantities, get used to them, so that when you see questions asking, is it derived or fundamental, you would know. All right, you would know. Okay, that's for question 15. Let's take question 16, which says, which of the following is a fundamental quantity? I think it's exactly the same as the previous question. Yes, exactly the same as the previous question. So, okay. Question 17 says, which of the following is a fundamental quantity? So you need to learn your fundamental quantities. There are about 8 of them. So the fundamental quantity here is electric current. All right, this is fundamental. Fundamental quantity is electric current. All of these are not. They are not fundamental. They are all derived quantities. So you must learn your fundamental quantities and know them. So they're like the basic quantities is from your fundamental quantities that will get your derived quantities, right? By combining your fundamental quantities, you get derived quantities. That's for question 17. So let's take on question 18. Says, which of the following physical quantities are derived? Which of the following physical quantities are derived? Area is derived, all right, so this is derived because area is length times length, right? So which is derived. Thrust is derived. Pressure is also derived, all right. So the only one that is not derived here is mass. The correct option is, the option that says 1, 2, and 3. 1, 2, and 3 are derived quantities. So the way around questions like this is learn your fundamental quantities. There are not a lot of them, about 8 of them. Learn your fundamental quantities. Okay, so you know all the quantities are derived. Fundamental quantities are like the basic quantities. And then derived quantities are gotten by, combining fundamental quantities, either by multiplying or dividing them. Yeah, so that's for question 18. Question 19 says, which of the following physical quantities is correctly paired with its corresponding SI unit? Okay, so which of them is correctly paired? So let's start with pressure. Pressure is force over area. The unit of force is Newton. Unit of area is meter squared. So this should have been Nm minus 2. So this is wrong. Okay, that's not the correct answer. Let's go to power. Power can be said to be work over time. And work is measured in joules. Time is measured in seconds. All right, so this is joules per second, or joule JS -1. All right. So the correct option is option C. Okay, but we'll still discuss the other ones. Density is mass over volume. That's kg meter cube. You see that? So kg per meter cube. Because volume is meter cube, right? So and mass is kg. You can rewrite that as kg m raised power minus 3. So it should have been minus 3 here. So this is wrong. Okay. And let's take the final one, specific latent. All right. For specific latent heat, your formula for specific latent heat is H is equal to M times L, right? L is your latent heat. So your L would just be H over M. Okay, so this is something you would do in, like when you do heat energy, right? But then your unit shall be, heat energy is in joules, all right? Heat energy is in joules per kilogram. So this guy here wouldn't be there. It's just supposed to be this two if it's for latent heat. So the correct option is option C, because the others do not match up with their, with their correct unit. That's for 19. Number 20 says, which of the following properties of a steel bar can be measured in terms of dimension of length only? So the correct answer is volume, all right? Because volume is, well, basically L times L times L. That's L cube, all right? So L cube, that's volume. Pressure is force over area. Within force, you would find seconds, because you have to do acceleration, right? So, and also you find mass. For density is mass over volume, which tells you the same thing, right? You're going to have kilogram, which is, mass, so it's not just going to be length. And then weight. Weight is a force, right? That's mass times acceleration. So you're going to have both kilogram and per second squared. So you also have time. So this is meters per second squared, right? So you also have time. So the one that only deals with length is volume. Volume. That's option B. Okay, that's 20. So let's do 21 now. Which of the following quantities are dimensionally independent? which of the following quantities are dimensionally independent? So we have the dielectric constant is dimensionally independent. You'll do this electricity when you learn about capacitance. Efficiency too is independent. It's just a ratio of work, so it's independent. Work, that will be work output over work input. That's efficiency. You do that when you do machines. The refractive index too is dimensionally independent. And there are many formulas for it, but they all cancel out. Speed in air over speed in just basically speed over speed, which will give you a value that is dimensionally independent. There's no dimension. That's what independent means, right? Or sine I over sine R, still dimensionally independent. So the correct answers are I, and IV. I, and IV. That's option D. 22 says, which of the following quantities has the same unit as energy? Okay, that will be work. Work has exactly the same unit as energy. Work has exactly the same unit as energy. Work and energy are pretty much the same thing, right? Work is basically change in energy, and the unit is joules. Joules. Okay. Power is joules per second. Force is newtons, and momentum is mass times velocity, which is kg meter per second. But the one that has the same unit as energy is joules. Work and energy have the same exact unit. Work is change in energy. All right, 23 says, which of the following set of quantities is fundamental? Okay, a full set that is fundamental, that will be option D. All right, length, mass, and time. So you need to learn your fundamental units. You must learn your fundamental units. There are 8 of them. All right, so there's length, there's mass, there's time. Quantities rather. There's length, there's mass, there's time. There is luminous intensity. There is luminous intensity. That's the unit is candela. There is current. Current unit is amperes, and there are like 2 or 3 others. But you need to just take your time and learn them, right? So that when you see questions like this, you know exactly what is or what is not. Okay, 24 says, which of the following statements about a spring balance and or a chemical balance is not correct? Okay, so the chemical balance operates on the principle of moments. That's true. All right, this is true. It is correct. So that's not the correct answer. It is correct. Chemical balance operates on the principle of moment. So it can, when you balance, it has like a chemical balance looks something like this, So when you balance anything on it, it could make it tilt, and then that'll show you what is heavy and stuff. So that's correct. That's correct. The spring balance operates on Hooke's law. This is also correct. The spring balance, operates on Hooke's law. This is also correct. The spring balance is used to measure the weight of objects. So it has like a spring, and then you hang your weight on it, and then it stretches down to tell you, and that's exactly Hooke's law. Hooke's law forms the relationship between force and extension. All right. So what it's basically saying is that the more the force or the weight you apply, the more the extension, which is how the spring balance operates exactly. So D is also true, as well as A. Let's take on C. C says that either may be used to measure the weight of a substance. Not quite. Okay, so chemical balance measures mass. All right, so it gives you your answer as mass. Spring balance measures weight. Now, it's true that if you multiply your mass by a constant value, which is the gravity, right, force of gravity, you will get weight. But then your chemical balance does not give you the weight of the substance, does not give you the weight of the substance unless as a primary output, right? It doesn't give you the weight, it gives you the mass. So by that, this is not correct. Okay. B says the reading on the spring balance changes over the surface of the earth. Why that of the chemical balance remains constant? That's true, because chemical balance measures mass and mass does not change, but spring balance measures weight and the acceleration due to gravity. So weight is mass times acceleration due to gravity, right? But this acceleration due to gravity changes, as you go from the equator towards the poles, it changes. So because of that, your spring balance changes over the surface of the earth. That's your reading, which is your weight, changes over the surface of the earth, while that of the chemical balance remains the same, because it's mass and mass is constant. So the correct answer is option C. Option C, because it is not correct. Your chemical balance does not measure weight; it only measures the mass of the substance or an object. Okay, so which of the following term has a different dimension from the others? All right, which of them has a different dimension from the others? Okay, let's go. So pressure is force over area. All right, pressure is force over area, which is going to be pressure is force over area, which is going to be Newton. Okay, fine, let's break down force. So that will be mass times acceleration, then times 1 over area, right? So mass times acceleration, your mass, okay, let's do acceleration. Acceleration, this is mass, times, acceleration is velocity over time. So velocity times 1 over time, then times 1 over area, right? So this will be mass times, now velocity is distance over time, all right? So I'll just say length times 1 over time times 1 over time, then area is 1 over length squared, all right? So 1 over length times length, all right? So we can cancel out this, can cancel out this. You just end up with mass, which is m in dimensional analysis now, not in dimensional analysis, all right? Then time, so, and they are both denominators, so this will be over t squared, and then length is also a denominator. So you can write this as mt minus 2 l minus 1, all right, or ml minus 1 t minus 2. Okay, so that's that for pressure. Okay, but we just know that pressure is force over area. Okay, and we know that from that we get this, but this is even good enough for us. So let's move on now to see torque. Now torque is moment, all right? So torque is basically force times distance, so it's different. Torque is force times distance. So force times distance. So this is basically whatever forces times distance, while this is whatever forces divided by what? Area, all right? Divided by distance squared. So you could also find the, stretch it out, but I don't think we need that to answer this question per se. Now, stress and strain. So stress is actually force over area. Stress is force over area. So it's exactly the same as pressure. And then strain is E over L, is the ratio of extension to length. So, but both extension and length, they are both, distance measurements. So this one here, it will cancel out. Your units will cancel out. So this is dimensionally independent. All right, dimensionally independent. So basically, it's just force over area divided by nothing. So it's basically just what? Force over area. So that means that C and A are the same. All right. Again, because strain is E over L and strain is nothing, right? It has no dimensions. Same here, would have force over area. Supposed to multiply strain, but strain is E over L, which is dimensionally what? Independent. So no dimensions. So basically it doesn't matter. You just end up with force over area. So I'll repeat, cos strain is, my handwriting is really bad, sorry. Strain is extension over length. That's both lengths, so they will cancel out. So strain has no unit, so this is just the force over area times nothing. So D is also what? Force over area. So the term that has a different dimension than the others is torque, because torque is not force over area. Torque is force times distance. All right, force times distance. So that's for question 25. Which of 26 says which of the following units is derived? Which of the following units is derived? The correct answer is N, newtons. All right. So you need to learn your fundamental quantities and fundamental units so that you'll be able to tell. So this is mass, which is fundamental. This is temperature, which is fundamental. This is length, which is fundamental. But force is derived. All right. Force is a combination of mass times acceleration, and acceleration itself is length over t squared. All right, so it's even derived from a derived unit. It's really derived. Okay, that's 26. So the answer is N, newtons, for force, because force is derived. 27 says which of the following is not fundamental? So again, you need to learn your fundamentals so that you can tell which one is not fundamental. I think there are just about 7 or 8 of them. All right, so the one that is not fundamental here is joules. All right, joules is not fundamental. All right, that's the unit for work. Candela is luminous intensity is fundamental. Just tells you, how bright, how luminous, how bright an object is. This is mass. All right, so that's fundamental, and then length is also fundamental. So the correct option is joules. So that's option A. 28. Which of the following physical quantities are derived? All right, are derived. Okay, so we've answered 28 before, I believe. Yes, we've answered 28 before. The one that is derived, the ones that are derived, area is derived, thrust is derived, pressure is derived. The only one that is fundamental is mass. And the way you do this is better you learn your fundamental units. There are about 8 of them. Learn your fundamental quantities and fundamental units, and then you can now tell which ones are not fundamental, which ones are derived, which ones are derived. So mass is obviously fundamental quantity, and so these 3 are derived. So that's 1, 2, and 3 are derived quantities. That's C. So that's the end, and those are all the questions on measurements, units, and measurement quantities and units. So good luck with your prep.